Welcome to another GCBASIC demonstration. This is an assembler deep dive. I'm going to show you a whole series of hidden gems with respect to assembler. GCBASIC has always supported the dialect called GCBASIC, always supported inline ASM and a thing called raw ASM. And the assemblers and linkers that you can use are all up on SourceForge, GCBASIC files tab, looking there for support files. This is important if you want to do assembly. I'm going to show you some new tricks. Well, why do you need to use assembly? If you don't need to use assembly, drop out of this now, or let it run in the background and then light the video. Okay, just don't drop out. Always light the video, always let it roll to the end, otherwise I get no recognition. Okay, but why does you need ASM in GCBASIC? To be quite frank, you don't, because we want to create portable code, and if you use the dialect, it will automatically generate optimized ASM, but some people need it as a teaching aiding. Some people need it for debugging, and there are some diehards that have contacted me and said, how do I support assembly? Well, I'm going to show you. Loads of assemblers that you can choose. I'm not going to stay on that page. Just go and look on SourceForge. Okay. So we're an open source compiler for PIC, LGT, and AVR, and we're cross-platform with common code translation if you use GCBASIC. The moment that you start using assembler, you are not cross-platform because you are going to be writing assembler for a specific chip. And GCBASIC, as I've said previously, has always supported assembly. Let me show you this diagram. I do use this diagram a lot, but let me just select a pen. There we go. We take the source program, normally in using the dialect of GCASM, of GCBASIC. It goes to a pre-processor, sucking in all the libraries that have been written, yours and your libraries and the standard libraries, pushes it into a code translator, just validates things and makes sure the syntax looks generally okay. It then pushes it through an assembler, and then it links it out and generates a machine code file. But along the way, it produces an assembly file that you can look at and a text and HTML file that you can look at. That's what it does. Core compiler. How about, shouldn't really say that, should it? It shouldn't say ASM up there, like AV. It just should say assembler. Because what you're going to do is have you're going to take a GCBASIC source file, but it's going to have a whole load of assembler in there. You need to have a header file to tell the GCBASIC toolchain what to do. And then you're just going to fill it full of ASM. And it will go through the pre-processor. It will realize what to do. It will then take the raw ASM and push it through an assembler, which is also just going to sort of ignore it generally. Okay, I'll tell you why it does it there in a moment. It's going to produce an output file. You can pass that output file into a linker, assembler, and then it will generate your machine code file. But why are there two boxes there? Because you can take advantage of some of the Great Cow Basic, like the old Great Cow Basic and the new GCBASIC compiler, and you can pre-process it, and it will go through the code translator, and you can refer and use the libraries. So you can use some of the libraries so that you can have a lot of assembler and then use the library. You can use your own libraries quite clearly, but if you want to do memory management, you could use the GCBASIC memory management, and then that saves a bit of a problem because you're not guessing where the memory is, because GCBASIC knows that layout and it will manage that for you. Then it will go into your assembly file, goes through the same route. So what we're going to look at is that, and what we're going to do is look at it on a real device. I'm using an old what's this, low pick count, PIC-Kit 2 low pick count demo board. All this will work on a PIC-Kit 2, PIC-Kit 3, PIC-Kit 4, PIC-Kit 5. I don't care what it works on. I'm going to be using PIC-Kit 2, PIC-Kit Plus, because it's the fastest thing on the planet. Right, let's have a look what we got into an IDE. Okay, I'm not going to be spending too much time looking at stuff today. Let's just get into the code. So what I've got, standard 2 lines at the top. Okay, let's zoom in case you can't see it. standard 2 lines at the top. Chip, it needs to know what chip it is because it's going to go through the compiler. Option explicit, define your variables if any variables are used. New command. This has been there for ages, just not been published because this is going to get hairy. Option, user code, code start, must finish with a colon, and a label that it's going to go to. That's the start of your program. If I press F6 and compile that up, I look in that source code, there's next to nothing in here. There is. Load a bump at the top, comments. There is. The definition of the list file, the include file, the configuration that has been set by GCBASIC, start vectors, and then the jump to your code start. There's not even an org in there. You have to manage everything. There's no init sys, there's nothing in here. It's empty. If you want to have no config, so you want to manage your own config, option, no config. Do that, look at the ASM, and we will see the config has gone. That's gone. No, but you've got an empty file here now to put your own ASM. That's always been there. What I'm going to show you is showing you one hidden gem. Option user code, code start. Now I need some code start because the rest of my demo program has all been commented out there. And you can already see, for those that know, this is assembly. Let's go back to the top. I've uncommented it. So you've always been able to insert raw ASM, just one line at a time. Bit of a pain, that makes it hard to read, hard to bring it in from other programs. So what I've done, I've gone raw ASM, open brace, and down the bottom I've got a close look. So anything in between there is raw ASM. I've got a label. I've defined some constants or addresses to memory spaces, which is in memory. I've got the org where I want to start my program. It could be org. The minimum that could be is org 4, I think. Init sys. I've written a new init sys specifically for this chip. Okay. Handcrafted this. Oh, fantastic. I'm sure this could be optimized, by the way. All right. I'm sure this could be optimized down. And then I've got clear the triz, set some LEDs, set a variable called LEDs, because that's in my address space, 1280. And then I'm going to flash some LEDs, F5. It's going to go through, pre-process it, pass it through, out to the PIC-AS tool, back out to PIC, and it's done it. I'll just prove it. Done. No errors. What's it doing? Look at the camera. It's flashing the LEDs. You might not believe me. I'll just erase that. I've erased it. Back in here, I've just recompiled it up. You'll see it do it. Go out to the camera. So I've got some form of assembler that's doing that. And it's absolutely, there's nothing really coming out from the GCBASIC toolchain in this. If we look at the that assembly again, but we're going to look at it for the PIC-AS. It's the same source essentially. This is all coming from the assembler that I've just typed out. Code start. Here's the start of raw ASM. Here is my assignments. This is the calls that I made out. So this is the exact call going out through the PIC-AS and it's working. So if we look in here, let me go back to that ASM. If I got my no config turned on, let me just put that back off, and that's how I should have had it. We'll look at the ASM. This is .s source for PIC-AS. You can see that Great Card Basis has listed out all these configs for you, and in reality, you can go and sort those out in the source. It's up to you how you do it. You can use any method to set the config. I don't really care. You can actually use orgs to do it, to be quite frank. If you look in the list for this, this is the list from PIC-AS just been produced. You can look if you wanted to set the configs, you can just use org now and just do what you like. It's down to you. You've got the freedom to do it. Whilst I'm here, I can show you something else though. How to use all this with inline as a inline GCBASIC might be the way to describe this. So what have I got? Same start, code start, looks like the same, but it looks like I've got some variables here, but down here I've closed the raw ASM, and then I've called two GCBASIC functions, init PPS and init USArt, and I've closed it after some more ASM. This is all ASM again, look, because I've opened a new block. I've said send H serial A, and then at the bottom I've got my init PPS. So I'm just going to send some stuff to a terminal. So we'll have a look at that on that screen. I'll have to pull the terminal screen across for you. Let me just put it here. I'll just clear that if you don't mind. Then I'm going to compile that and send it up. So what I've done here, I've got inline GCBASIC. Inline GCBASIC. It's not inline ASM. It's the other way around. And look, it's sending a letter A. So I'm using the serial routines of GCBASIC inside assembler. Now, I can also do this. I can also use the memory management. Now, the memory, as you move things around in assembly, you've got to know all the memory, but you don't in reality. You don't have to, because you can use GCBASIC to do some of this stuff. Let's have a look at this this source. We'll open up the .s source, shall we? In here, in the .s source, we've got references to a load. Oh, look, a load more variables, and they're string variables. They're all starting to come in, and so it's a good practice, right, to ensure that you don't mix up. Look, I've got a bit of 1280 and 1280. That's looks a bit odd. I'm surprised the LEDs are actually working, but never mind. So what I'm going to do, I'm going to dimension these variables: LED, DLY1, DLY3. Don't do things live as bytes, and then I'm going to initialize them. In actual fact, can I initialize them inside the ASM? No, but I'd have to do them here because I'm using GCBASIC for the memory management. I should set this to 0 really, shouldn't I? Because I'm initializing them. These are the three variables I've got in use. I can now take this out. Now, let me just look at that. We'll look at what it's done inside of the assembly. Compiled it successfully. It's now sorted out this memory for us. Now, great, GCBASIC is managing the variables, and there's no overlap here of memory addresses, look, because it knows what it's doing. So what we've got is a method of using GCBASIC inline. It's fantastic, it really is. You can do some great stuff. So now in here, I've got the same call init, etc. I'll just program that out. We'll have a look at the terminal, I guess. I'll clear that down. That's the programming event happening, the corruption, and we are away. Be interested to see if I can send a string. I have not tried this. Print string. I don't know if this will work. I think you have to write your own routines for larger string handling. I think there may be errors. Yeah, you have to write your own string handling routines, but the basic, some of the basic functions work. So like hserial send clearly works because it's a primitive. It's a very low level call. I'll put that back. And so there are some learning experiences on how much of the libraries you can use, but certainly the basics all work. LCD should work fine, etc. So now what we've got, looking out at the camera, same code, but what we've got, I've started to use the serial at the same time, which is fantastic. That's still chirping away, and I've got this inline code going on at the same time. So it's very clever. Not clever. It's so what you're seeing here, new command is just recap. User code start, you get nothing. You just need a label and you'll get nothing. You've got option no config, been there a very long time. Most people think it's for bootloaders. It's not. It's also can be used for this concept of blocks of code. So that's a block of code, that's a block of code, blocks of code, raw assembler. You need some constants. Not even the constants exist, to be quite frank. There are no constants. The compiler is empty. You have to start from first principles. And then for the serial, I've used the standard GCBASIC defines to set up the serial, and then in itsys I took that from PIC-info. So you can use pieces, cut pieces in and out. Hence this init PPS, init sys. Here, normally they'd be handled fully automatically by GCBASIC. They are not. Let me just have a look at that just to prove that. Oh, it does do an R call to init sys, so I don't actually need to do that init sys the second time. Oh, there is a reason why that's important, because the init, I should put my init sys before that. I can, let me just change that around, do a bit more optimization. If that call, where do I want to put that call? Put it the first call. I don't think that's, I still think that's not going to work. No, it's not going to work because the init sys will still not come early enough in the assembler. Yeah, you see, you've already, it should work, but not, you're going to have to sort of work all this out as you're coming through the programs. Anyway, what you've seen is that inline GCBASIC blocks of raw assembler specific for this chip. If I try to compile that up for, I don't know, in GCBASIC, I would simply go 16 FF, compile that, and all the magic would happen. But in reality, this is going to throw 1,001 errors because I've got all sorts of different issues with things not existing. All that I'm surprised. Well, the config will work because that's been picked up by GCBASIC. If I had no config, all the memory maps worked fine. That's all got sorted out for us. Look, 32. We've all got unique addresses for all the strings, so you can do some level of portability. But the actual this won't initialize very much because the init sys will be completely messed up. It will be creating variables rather than talking to registers. It's going to do things that oh, here you go. Init sys didn't even do any of the block because it doesn't know about it. It just does not know how to handle this lot, and quite rightly so. We look what's going on. Init USR, where's my init sys? Yeah, they might have some, it might work, it might not. You'd have to go through it because you're in assembler. All bets are off. Right, deep dive, hidden gems, long video, let it run to the end, press like, subscribe, do all the right things. Back to my PowerPoint. Enjoy.